Welcome to Scientifier. Let's jump into thermodynamics. The word comes from two Greek roots, therm meaning heat and dynamics meaning power. So thermodynamics originally means the study of heat and power. By extension, it is the science of energy. The first law of thermodynamics is the conservation of energy principle. It means the energy entering a system equals the energy stored in it plus the energy that leaves. Surely I have represented energy by arrows. The second law of thermodynamics says heat flows from hot to cold, never the reverse. It also means some energy becomes unusable. It is called entropy and it always increases. The thermodynamics can be studied in two ways. The microscopic approach looks at the big picture using things we can measure like pressure without worrying about molecules. The microscopic approach zooms in. It looks at the behavior of individual particles using statistics to explain how energy moves. Dimensions are physical quantities like mass, length, and time. Units are how we measure them, like kilograms, meters, and seconds. We use the SI system in science and engineering generally. In thermodynamics, primary dimensions are basic quantities like length, mass, and time. Derived dimensions like volume combine these. Imagine a cube, a square, and a pyramid, each with sides of the same length. The cube has the greatest volume and mass because volume is a derived dimension based on length. If a pyramid hits a square, the lighter pyramid moves away faster, but if a sphere hits the square moves faster this time, since it is lighter. The principle of homogeneity states that the unit of each part of an equation must be the same. For example, we cannot add a banana to an apple, but an apple plus an apple gives two apples. Similarly, banana plus banana gives two bananas. So we apply the same method or principle for orange too. Which of the following equations are valid? So which equations are valid? In real addition, we cannot add calories to joule, but we can add joules to joule. The same applies to pressure or power. We can only add quantities with the same units. A system is what we are studying. The boundaries separate the system from everything else, the surroundings. Energy can cross boundaries, mass might too. There are two main systems in thermodynamics, closed system and open system. In thermodynamics, a closed system doesn't let mass cross its boundaries, but energy can move freely. Imagine a gas trapped in a cylinder by a moving piston. The gas stays inside, but the heat can enter or leave. In an open system, the mass and energy both flow through the boundaries. Think of air flowing through a nozzle. Both mass and energy pass freely in and out. Properties of a system. Let's look at two system properties: density, symbolized by ρ, and specific volume, V. Density measures how much mass fits in a given volume. For example, gold has a very high density, meaning it is heavy for its size. Silver, which roughly half gold's density, occupies more space for the same mass. Specific volume is the opposite. It is the volume occupied per unit mass. So silver has a higher specific volume than gold. A system state is defined by properties like temperature, pressure, and volume. When these stay constant, the system is said to be in equilibrium. For example, if two systems have the same temperature, no heat flows between them. But if their temperatures are different, heat transfers from the hotter to the cooler one until both reach the same temperature, and that is thermal equilibrium. A process is a change in a system state. If it returns to its starting point, that is a cycle. In the diagram below, the curve shows a process path, and a closed loop means the system completes a cycle. The Zeroth law of thermodynamics states that if two bodies are in thermal equilibrium with the third body, they are also in thermal equilibrium with each other. Now, we estimate absolute zero by observing how the pressure of a gas drops as the temperature decreases. If we extend the trend, the pressure reaches zero at 0 Kelvin. Define the lowest limit of temperature. Law is represented by three rooms: square, circle, and triangle. Pressure is the force applied per unit area. As shown below, the same force on two different areas creates different pressures. The smaller area has higher pressure, causing deformation in the beam. The larger area spreads the force, resulting in lower pressure and no deformation at all. This was our first video. If you enjoy science and energy content like this, please subscribe, like, and share. It really helps grow our fresh and curious new channel. And remember, everything is energy and matter, and that matters.